Thanks. All right. My name is Jon Reynolds. I've been developing in Python for the last 6 years. Degree in software engineering from about 10 years ago. So could call myself a programmer, but I've also been in oil and gas and the geology engineering departments for the last 12 years as well. So I'm your mixture of a part scientist, part programmer. So overall know-it-all. So. I'm just going to be talking today about making charts and graphs in Python outside of matplotlib, however you want to call it. I'm not dissing matplotlib. I use it every day, but sometimes I need to make something that doesn't conform to its shape, or if I want something else, it's very easy to make it in Python. And also, you can learn from other programming languages. Even if you work in a Microsoft shop, there's chances that you're going to work in other languages. I started out in Java, went to C#, now I'm in Python, and who knows what crazy programming name I'm going to be using 10 years from now. And I'm not a big book guy, but I'm actually pushing a book today. I buy a ton of tech books when I was in college. I've probably bought one in the last 5 years, but there is one good one that I'm actually going to push today. And then just about my programming style, I don't like to use a lot of libraries. I don't like to pull in stuff as much as I can. If I need to do something very simple, like if I calculate distance between 2 points, I'm just going to write a function for that. I learn how to do a little bit of trig, maybe a little curvature of the earth. I get a little smarter, my code is a lot smaller, and maybe runs faster. So that's my thinking. But I still use matplotlib, numpy, scipy, scipy, PyODBC, SQL, pandas. I'm not completely crazy. Other smarter people have written things much better than I have. And then also, I want to encourage people to write code outside of their comfort space as much as possible. Take a page from writers, Stephen King, stuff like that. If you're wanting to do something outside of your comfort zone, schedule that time. Take 7:30 to 8:30 every morning. Write a little bit of code on something that you don't normally do, and after a year you'll have just a library of other things in your back pocket. So that's my big mindset that I want to put in front of you today, where I'm coming from, what I'm thinking about. And to make some charts, you just have some basic concepts. You've got your frame of the outside basic window. I have a canvas. Where do I want to draw things? And I'm just using some simple items here. I've got lines, rectangles, ellipses, very basic concepts. Even some polygons. And these all have very simple attributes. They have an X, Y location. We start at the top left. X is how far over to the right. Y is how far down. Very simple. I'm going to keep track of these things and try to understand and just keep track of these so that I can loop through these items and draw them as efficiently as possible. And within Python, you can do things very simply, like create a color gradient. This is just me taking a couple lines of code where right up here, I define my window. I've got a window that's 200 pixels high, 400 pixels wide, and then I do a little math to get my color gradients to go from blue to pink or magenta, and then down here I loop through those 100 different increments, and I just plot 100 rectangles on top of next to each other, and it gives me the illusion of a color gradient. And actually at the appendix I've got a snippet to show you guys how to convert from one RGB color to another and actually get the code for this gradient. So there's very, very short amount of code, I can do some cool colors. So matplotlib is fantastic. You can get your tracks set up, you can plot data, you can scroll, you can zoom in and out. Very nice software. But it doesn't look like the plots that I have to do in oil and gas. So I wanted to make some stuff that kind of looks like those tracks. So I just use, I'm going to pronounce it wrong, tkinter, how do you say it? Tkinter. I use that library that comes within Python. So it's part of the base package. You don't have to import anything else. And what I'm able to do is plot 2D graphics within here. So I'm trying to do my best to show what it looks like in Matplotlib and also what it looks like once I figure out the math and how to space all these things out. And I've got my individual tracks and data. Now, another reason that I would want to do this is I want to be interactive with the data. I don't just want to see it. If something's wrong with the data, I want to be interactive and change it. I want to get rid of bad data points. I want to use the good ones only. So I'm going to show some stuff later on that as well. Now, how do I do that? I've got some space that I want to work in. I've defined my X, my Y. I've got some data. All I need to do is understand the scale. From this one right here, I'm going from 0 to 150. And what I would do is I would take my data, I would understand my scale. I'm going from 0 to 150. Understand that first data point, take it into a very simple formula. It's just a little bit of algebra, understanding where that data point falls within the scale. And then I have my X point. I do that for all my data pieces, and I draw a line in between them, and then it all plots out real nice and even. So it's not a whole lot of math to go ahead and rescale your data into whatever you want to display. Now here's the really big, fancy, eye candy snapshot. I've got a bunch of data. I work in oil and gas, so these are measurements from taken from an oil and gas well. The depths are a little hard to see, but this is 12,350 feet down. So this is data taken from 2 miles underground. These are measurements taken every half foot. So I've got very high sampled data. And what I'm able to do is go ahead and take these input curves, I run a mathematical model, and then, of course, I make my calculations the prettiest with the most colors and everything. It's just the sales thing. But here, I've got 2 frames. I've got a frame for my header, so I can list out the different curves and their scales. So I have one frame up there, and then I've got a log frame down here where I'm actually graphing out all my different tracks. Each track is kind of its own little space where I've rescaled each of the data points and looped through them and drawn them. And you can even do the math very quickly to do a logarithmic scale. This is in a log 10. This is a resistivity curve that goes from 0.2 to 2,000 very quickly. What I've done here, that just like the color gradients I showed earlier where I did 100 different rectangles to present that color gradient, I did the same thing here where I have rectangles to show that scale right here, where when the curve increases to the right, color feels darker. If it's to the left, color feels lighter. Or if I want to, I can do a polygon and have all my rescaling data points, draw one to the right, connect back up to the top, and just do a polygon fill. So you can do a lot of really graphically pleasing things pretty simply. This is just more the eye candy side. I did an XML template to save all these objects. So I have in XML, I have my tracks and I have my curves. My curves are the data points and my tracks are just those individual tracks. And I keep track in XML, the width, the type of the track, how many grid divisions I want in the background, if I want any bold divisions. And then on my curve, just what kind of curve it is, which track number it goes in, its colors and such, and thicknesses. That way, I have a list of objects that I can flip through and just loop through all of these data points to get plotted out there. Now, the interactivity was the whole reason for me making my own plotting software so that I could interact with the data. I want to be able to edit the data. I have an example here where it's very, this was just a bad example, but where this isn't real, I want to make it look more like a nose, I suppose. So I was able to interact here by using some click events. I was just able to keep track of the left mouse clicks, and then when I right click, it would go ahead and run a mathematical model, do some interpolation, and refresh and display the data again. Also, the benefit is also that I can interactively edit what I'm seeing. So I added a menu where I could add curves to the layout. I could move curves around if I put them in the wrong track by accident. I could delete stuff, rename stuff in the data, all kinds of pieces here. And this, I have a little pop-up where I can select which curve I want, which track I want to put it in, give it a scale, color, all those things. So this is the real big benefit to me. Matplotlib is great, but then I have to go back, change my code, refresh. This was just a way for me to interactively not have to keep restarting my program. All right. And then I don't want to go through any code today. I'm just talking big picture stuff today. But what this is just showing a cross plot where I've drawn the grids in the background, I've drawn my data points, I've added all the text and labels and everything like that, and it's a very short amount of code. So it's not a great deal of code to actually do this yourself. So that's my talk for the most part. With some simple ratios and algebra, you can do your own plotting software if you have something that you want to customize. Also, I'm a big pusher of books, maybe not technology books, but to continue reading. And one of the things I do is I buy a book every paycheck. I may not read one, but I buy one anyways. So I've got one in the queue. Here's the book that I was pushing for C#, Practical C# Charts and Graphs. This book shows you all the geometry on scaling, all of this stuff. It also, because it's C#, it'll go into the libraries to do 3D plotting and some libraries that are in C# that let you do some other cooler stuff. I just wanted to include the book and have it as a reference there. And then I'll have this out on the internet. This has the appendix for the code to go from HTML to RGB and back to HTML, and actually the color gradient code where I loop through from one RGB code to another. So I'll share that out there. All right. How did I do? Pretty close? All right, that's all my talk. If you guys have any questions, I'm going to hang out, and you're welcome to hit me up for questions later.